we thought they were the perfect speakers for today, sharing some learnings out of those machine learning projects that they've done, and most of them are actually running in real production systems and industries, right? So they certainly have a lot of experience on this one. And yeah, Victor has come today to share those, and to also share some of the mistakes ML6 found to be quite common in the industry. So that's, in terms of introduction, over to you, Victor.
Thanks, Yuri. Thanks. Awesome introduction. So thanks for being here in this warm Monday evening. Your heads might already be full. It was an awesome session so far and very, very interesting insights. So I hope there is a little bit more room for the use cases I have to share. So my name is Victor. I'm a machine learning engineer at ML6. So a machine learning engineer, meaning a little bit more technical as well. This means it's going to be a more pragmatic, more practical approach. And so, yeah, the use cases are just a way to bring you some tips and tricks that we found to work over the years. So maybe let's start very, very quickly with what ML6 actually is and does. So ML6 is a services company, which means we usually get to work on these cool like edge cases or more custom solutions that just a normal or like an off-the-shelf AI solution cannot handle. And so to do that, we have more than 80 machine learning engineers. Most of them are located in Belgium, but we also have an office in Germany and also in the Netherlands, the UK, and recently Switzerland as well. We're also the largest and the fastest growing AI company in Belgium, at least, according to Deloitte's Fast 50. And we've been a Google Cloud machine learning specialization partner for a while now. This means that we usually work on Google Cloud, which doesn't mean that we're limited to it, but we like the environment. So it's a nice place to work as a data scientist. We have some trusted open source contributions as well. And 15% of our workforce is fully dedicated to machine learning research, which you really can't do without in this sector. So it's kind of a must to stay on top of things, especially if you're aiming to get into the market with those like custom solutions and the more state-of-the-art stuff. Now, sales pitch aside, what I'm going to talk about today is how to implement machine learning throughout production. And with production, I mean both production in a software term in which people use it, it's live, it's being used, but also production a little bit more in the direction of actual manufacturing, but that's only the last case. So we'll see how that goes. But I want to start off with this. Actually, it was by the previous speaker already, so Tobias already went over this, but it's very important. So it came back the second time and it's very important. So this means the ML code was actually the first icon that was showed. It's very, very easy these days to get machine learning code working, thanks to the magic of open source. And like was talked about in the earlier sessions as well, with online courses and junior data scientists can actually get their hands on this ML code really, really quickly and get something to work really, really fast. But the main insight here is that is by far not the hardest thing about a machine learning project. There is so much more around it. So next to, of course, the use cases and the business decisions or the strategy that have to be devised, there's also a lot more technical stuff that also has to happen. So there's configuration, data collection, data verification. So yeah, some of the previous speakers already talked about this. Serving infrastructure, there's both the cloud, there's on-premise, there's all of these different ways, monitoring, process management tools, analysis tools. There's so many more things that come into play when you want to scale a machine learning system out to like larger scale. And this is also a bit about that. So this is already a quite old picture. It's from 2015, from actually a great paper written by the people at Google about the hidden technical debt of machine learning systems and how these machine learning systems are actually harder than normal software development systems because they incur so much more uncertainty and so much more technical debt that they're harder to manage. So it's definitely a good read. If you have time, by all means, screenshot this one so that you can later look it up. Now, a little bit of foundation. What we see all the time is that there's different kinds of projects out there. So for now, the discussion was mostly on internal systems, right? On a large company that wants to use AI or machine learning in their own systems. We as a consultancy company see it more on the other way. So we see like smaller or also manufacturing companies that don't actually have this AI capability yet, or the IT capability yet, and they actually want to start with it. So you have different scales, let's say, in which they outsource this kind of machine learning projects. And so, yeah, you probably know all of these, like so POC, prototype, pilot, and production. Production is even probably bigger than the bubble you see right here. It's already comically big, but it can be even bigger. So the moment you actually start using a system, depending on which system, of course, but the moment you start using the system in production, it gets huge in terms of management, in terms of effort, especially, and I'll go more into depth in the use cases, especially when you do it on the production floor. This makes it so much harder because it has a real life impact on the actual machines. And so what we see a lot of the time, and I talked about this before, is the open source and like the online courses and all of these things that are out there. They actually usually mean that you can get a really, really good result really fast. So you can already show something like a POC, a proof of concept. You can already show that the technology will work. You already have a demo, but it's in a sterile environment, right? It's isolated. So you have the data somewhere in a bucket, or you already know where the data is and it's already structured. And then you just have to pre-process it and do that kind of machine learning code, right? But what we see then is that companies that aren't very experienced with this kind of technology want to jump straight into production with that. And that's a big no-no. So especially in these kinds of like I said before, the technical debt is so huge that you have to take these steps at every single step of the line. So you can't just jump all of the previous, all of the intermediary stages, let's say, especially in production again. But yeah, we see it all over the place. So if there's only one thing to remember from this talk, let it be this: give it time. They're not easy. They're harder than they expect, than they look. Especially, and it's so sweet if you have a good POC, just use it. It should be simple. It isn't. So yeah, there's a lot more to it than that. All right, but let's take things practical. I've prepared 3 cases that I'll go over and then just first explain them and then go a little bit more into some of the learnings or like some tips and tricks around them. So let's start with a relatively small one, and that is actually relatively bite-sized. So a case that we did was production capacity planning. There's several more like this. This is usually just optimization of planning, of scheduling, of bin packing, for example, in a truck, let's say. So these are all very similar. It's just optimization. And the idea here is that you have 4 production lines and you have several products that you want to schedule on those production lines, right? So here they're just scheduled randomly. This is definitely not a good schedule. But even only with 4 products, you already have 24 different configurations in which you could put this system. Of course, there's in the real world, there's constraints and everything, but right now let's just take it on a more high level. And it's 24. So that's manageable, right? You can have planner, you can have a single planner and work that out in Excel or something. But the moment you have 8 of these products, things already go way high. So you now have 40,320 possible combinations of schedules to work out, right? And this is already a full-man team, a few-man team that has to work on this full-time. So this is already a lot more difficult. Of course, there is normal planners as well, and a computer can go through 40,320 possible solutions, no problem. But things get worse the more products you have. And the moment you're at 46 of these products, things get unwieldy, to say the least. And so there is different ways to solve this. But what we've seen is that there are several machine learning algorithms that can do this quite well. Just like you might have seen these AI systems play chess or play Go. In Go, you can't calculate all the solutions, so you need some kind of intuition, if I may call it like that. Technically, that's not correct, but let's call it like that. And in that sense, it can usually do a lot better than just normal mathematical approaches. So this is already one way of doing production capacity planning with machine learning. So what are some thoughts with this, right? So this can actually be a very good starting point, because as far as a product goes, or as far as a use case goes, it can already add value before actually going into production. because the idea is that you could give this as a tool to just key people, like for example, the planner people that might be doing this right now with either specialized software or Excel even. This is something what we've seen before. So if you just give these people this tool, they already can expect value from it, right? You just need the actual planning, the optimal planning, or like the suboptimal planning as best that you can get it, and you have value. And this is a very good starting point because it's very fast to develop. You can usually do it with an in-house data scientist, and you don't need to deal with as much of the technical debt that I was talking about before. So if you're just starting out, these kind of cases are actually really nice because they're isolated by design. They don't have to steer any machine. They don't have to deal with too much data. It's usually just relatively isolated, and that's where it already can offer some value. Now, if we ramp it up a little bit, there is a second case. So what if you want to make a smart real estate search, right? So if you've ever talked to a real estate broker, the real estate broker 101 is you have to find premises, then you have to analyze those premises, or like those plots or of land or the buildings on top of them. And then you have to find matching companies or matching clients that want to invest in that specific premise, right? So you have to match, you have to do the matching, and that's the main goal. Of course, you have to negotiate with all the stakeholders, and the last step should be profit if you're doing well. And so at every step of the way, I can give some thoughts, right? So there is find premises. This applies to a lot of things. If you just, especially even computer vision can be used by this. But so open data should always be a first stop, right? So open data, there is so much data out there. Universities are creating so much data that we don't even know what to do with it sometimes. And so it can be very vast and very useful. In this case, for example, OpenStreetMap, which is basically the open source version of Google Maps, can already do a whole lot in this use case. So it's definitely worth starting out just looking at what is out there. Also, specifically then on real estate, a country's data portal can be hit or miss. In our case, in Belgium, it was superb. And actually not even Belgium, it was Flanders, specifically the Flanders.be website. They actually have super good open data, and it was very, very easy to just get it. And you basically had every plot every planned area basically in Flanders, just in an open data set. So that was super good. And then also what we saw is that paid data is very, very useful, but is not necessarily better or better quality. You should still use it, but don't expect it to be like the best of the best in comparison to open data. It might be, but it might also not be. So it's still just as much work down the line as might open data be. Now, if you want to analyze the premise, this is a big one actually. Data versioning is essential when transcending the POC phase. So this was also talked about before, is that you have to put these systems into place. You have to automate the CI/CD, like was said before as well, like Maddy said. And data versioning is one of those, right? So especially with machine learning, you want to know what data a certain machine learning model was trained on and have that data lineage, is what it's called. So you have to know where the data come from, what transformations were done on it, and what models were trained, and then do that versioning if you change things up. So this is already quite a big one. Cloud services are usually very, very capable in this respect. It might also be cloud on-premise. If you do it on-premise, like on bare metal machines, it might be harder to implement, but there are tools out there. But so cloud services are usually quite good at it. I've put in here BigQuery because we use Google Cloud. It's usually our tool of choice, and it has versioning built in, but don't have to use it, of course. And then also Kubeflow is rapidly becoming one of our favorite tools of choice, which just means that Kubeflow is like this whole setup you can put on top of Kubernetes to do machine learning with. So it has Kubeflow pipelines to do all kinds of transformations. It has Kubeflow serving or KF serving, sorry, to do deployments and so on and so on. So it's a really good, it's now in version 1.2, if I'm not mistaken. So it's already quite mature. So definitely check it out if you haven't yet. Also now with finding the matching companies, so this is where the actual machine learning code from the previous picture would come into play, right? And then simple can often outperform complex. depending on the case. And this was already said in the panel discussion beforehand, is don't just throw technology at it. I completely agree with the experts here. Don't throw technology at it, just see what the use case is and then just use tech to solve it. And whatever tech that might be, doesn't really matter that much. The end user won't mind. If you can use machine learning, cool, awesome, but you don't have to. And in this case, we did use machine learning, but not the like deep learning crazy approaches. Sometimes classical machine learning can already go a long way. And then, as was said again as well, is explainability is as valuable as a prediction itself. So in this case, but also on the shop floor, on wherever you want to use it, if people are going to count on your predictions to make their decisions, you're going to have to explain them, because at this point, no one will believe you point blank. And then, of course, negotiating with all the stakeholders is still a job for humanoids. We're not there yet. Maybe best that we're not there yet. So that was the chain of this specific use case. And then there is a final use case, and this was actually done on the shop floor, right? So this is an actual production environment, a manufacturing environment. And the idea here is that you have rugs that go through a machine, and they're actually cut on the sides. And here you can clearly see, let me just grab my pointer. Here you can clearly see that this kind of textile bar is not the same as the actual rug, which is on the right side, right? So we have to kind of detect where that folding line is, and then they'll just fold the textile part beneath the rug so that you don't see it. This is byproduct. But this idea of using computer vision to steer a machine is all over the place. The people at Porsche have talked about it already. But so it's a bigger project, right? It's definitely, the machine learning here isn't specifically super hard, but the integration is a lot harder. And so this is then the result that you would see is the rug goes through the machine, and you just detect the folding line throughout the whole rug. Now, here you come into a sort of hybrid approach, because I'm a big fan of the cloud. I've seen in chat that someone isn't, or at least poses questions, and rightfully so. But so far, it's quite mature in what tools you can use there. So far, I'm quite a big fan. But in this case, for example, you couldn't quite use it because it wasn't fast enough. That's always a big issue with the cloud. It's not fast enough to do actual real-time predictions if it's on millisecond basis, right? If you have to basically steer the machine, you don't have time to go to an API and back. And then you have to do this whole hybrid approach in which you have like the camera on the actual conveyor belt. Then you have a sort of edge device, a computation device that can do machine learning on edge. And then you have some sort of feedback interface that tells the user what the output of the model was. But then you have this whole system behind it, in which you have to say, okay, if the model wasn't good or did wrong predictions, then you want to store that feedback to then later retrain those models and make it better and better over time, because that won't happen by itself. All right, so time to finish. This is the last one. So integration takes a lot of time. In these kinds of cases, please don't underestimate integration. It's huge. If you have to be able to let your models talk to the actual machine, it will take 10 times the amount of time. And so really plan for that. The POC will probably change a whole lot in this whole system. So don't skip those steps, like I said before. Use the cloud wherever possible. If you don't, make sure you do have DevOps and IT that can support these kinds of projects. If not, first build out that fundamental, because otherwise you're going to fall flat with this kind of project. And then possibly start with a preliminary project like quality control, because quality control is already on the shop floor. It already works with the same kind of data, but it doesn't have to steer the machine yet. So it doesn't have this integration part yet, and that's still the biggest part. So again, don't forget integration. It can make machine learning engineers cry. It can make data scientists cry. So don't do that to them. If there's any questions, I will probably be at the debrief sessions if you have any more questions personally to me. And thanks for listening.
Thanks so much, Victor. Super interesting. I really liked the presentation. One quick question maybe from my side, because there isn't I think there isn't one in the chat yet, but so of those use cases, right? So you immediately kind of talked about like how to deploy those machine learning and the IT platforms and systems and so forth, and also kind of get there, right? But usually the people that are doing the rug folding, doing the other use cases, right? The domain experts that are kind of doing this day in, day out, they're not necessarily AI experts, and they don't necessarily have, at least out of my experience, any some may have some experience around what's possible and what's not with machine learning. But how do you bridge that gap between people that are very much into their kind of, this is how I do prediction, this is how I do maintain the machinery, but then what's possible with machine learning? How do you come to those solutions in the end with those people? What's the way it's similar as Tobias described it. Like there's probably some ideas. How do you do that at ML6 usually?
Actually, that's a very good question. So one of the things that we try to do as much as possible is, of course, explain the technology. Like that's probably where it starts anyhow. So yeah, having the knowledge on what the machine learning stuff can do and what it can do is a first. But what is then the other thing is that usually what you find is that people already have a decent idea, especially if you look very well, of what their issues are. And then it's just a question of trying to spot if it's possible to do it with machine learning. So in our case, we have to kind of filter for the machine learning projects, right? Because that's what our expertise is in. But usually that doesn't really matter to the people, to our clients, right? They just want to have a solution for their problem. And so if you do a workshop, or if you go with these people through the shop floor and just see how these things are happening, you can usually already find different problems or different pain points or different frustrations. And then it's just a matter of like listing them up and then trying to figure out how can we solve this. And then it's just basically you just need one person that knows what ML can do, and then just offer it as a tool, because that's in the end all that there is to it. It's just another tool to try to solve problems that usually weren't possible to solve before, but it's still a tool. And so in the end, it's just the most important part is to know about the problems. And then in the end, if you have this kind of knowledge, it's just relatively easy to just say, okay, this is machine learning, or this is not machine learning. And especially depending on the data, if you have data and labels, it's always possible to do machine learning as well.
Cool, perfect. Thanks so much. That's helpful. I would say with that, also given that we're